So the day before the test, we did the polynomial sign charts and inequalities. And then yesterday, we reviewed over some rational stuff, and so that we could actually start talking about rational inequalities and graphing that. So if you could do the polynomial sign charts, the sign chart part of this is going to be relatively the same. Let me tell you what I know about the what you learned last year and kind of what you didn't, because y'all started rationals and then spring break happened, and then you were on spring break until like August. So I know some of it was taught in the classroom. You never tested over it. I don't know if it was in Edgenuity, maybe it was, but even if it was, I don't know that you like really learned it. So I know there may be some gaps, and you don't, basically I'm pretty confident that you don't understand it as well as you should at this point. So I do know that going in, so don't freak out, okay? But there are some things that you absolutely should know about rationals so far, at least, to help us, today and whatnot. So let's first of all talk about rational inequalities. This pretty much says the same thing as what it said for polynomials. So it says given a rational function, we can have a rational inequality, just like we could have a polynomial inequality. Really, we could have it for any function. So if you say that f of x is anything other than equal to something, then it's an inequality. That's the idea of an inequality. So the inequality f of x is greater than 0 is true when f of x is positive. Should be painfully obvious. Okay. The inequality f of x is less than 0 is true when f of x is negative. Okay. So hopefully that's pretty much a no-brainer. Okay, so let's do this looking at a graph. So it says to look at this function. So we talked yesterday about what rational numbers are. Rational numbers can be represented as a fraction. Just because you have a function that has a fraction does not necessarily mean it's rational. This is a rational function. However, if I have 2x or 2 plus x over 5, even though that's a fraction, that's not a rational function because the denominator doesn't have a variable in it. So to be a rational function, you have to have variables in the numerator and the denominator, basically. Okay? So here's a graph of a rational function. Tell me what goes between this section of the graph and this section of the graph. What should be in between, or what is in between there that we don't see? Starts with an A. An asymptote. Very good. And it's not an asymptote. Mrs. Archer, who's a very good friend of mine, says asymptote, so we have to make fun of her every time. But it's an asymptote. So we're going to draw that in. We never make them solid lines. They're always dotted lines because, yes, they're part of the graph, but it's not really a vertical line in the graph. And then we have another asymptote right here. Okay. So that means that those parts of the graph are going to get really close to that, but never actually make it there. So if I want to name all of the intervals for which f of x is greater than 0, then I have this part, and this part, and this part. Okay. So remember we're talking about y, but we write about x. And so from negative infinity, start at negative infinity, and I go all the way to negative 3. I never include my infinities, but I'm also not going to make it all the way to negative 3 because there's an asymptote there. Then that's going to be a union with, I start at negative 1, and I go all the way to 2, but 1 I do not include because I can't include the 0 because it says greater than, not greater than or equal to. And I don't include the 2 because there's an asymptote. And then this third piece, I'm starting at 4. I do not include the 4 because it's can't be equal to 0, and I go to infinity. Okay. Everybody good so far? Okay. So then we're going to name all the intervals for which f of x is less than 0. So I'm going to start at negative 3, but I don't actually include it because of the asymptote. I'm going to go to negative 1. I don't include it because I can't include 0. Start back over at 2. Don't include it because of the asymptote. go to 4. Don't include it because I can't include 0. Okay. Any questions at this point? Okay. So for the polynomials that we were dealing with, the only place that the function could change from negative to positive or vice versa was at a 0 because it had to pass through the axis. Well, for rationals, it happens when it passes through the x-axis, but it also can happen at the asymptotes. See that there? So it says, notice that a rational function switches signs at both zeros and vertical asymptotes. So we have to take both into account when we're doing our sign chart. Our directions for the sign chart are pretty much the same. To set it equal to 0, factor if you can, plot the points, but then it does say here that asymptotes always get an open circle, okay? So the open or closed circle for the zeros depends on the inequality sign, if there is one, but the asymptotes, no matter what, are always open circles because we're not going to cross them, okay? All right, so let's look at number 1. It says create a sign chart. All right, so there's really nothing to factor. You can set it equal to 0, but like that's as exciting as it gets. So tell me, first of all, the asymptotes happen when the function is undefined. So what number would I substitute into this function to make it undefined? -2, exactly. So, and that means that's where my asymptote is. So we get our asymptotes from the zeros of the denominator. We get our actual zeros from the zeros of the numerator, okay? So if I substitute in a -5 here, that gives me 0. So my zeros come from the numerator, got that -5. The asymptotes, now there may be horizontal asymptotes in these. We'll get to that later. Right now, the only thing that affects the signs are the vertical asymptotes. So I need my vertical asymptote. And they are lines, so we always write them as equations of lines. And since if I set this equal to 0 and solve that, I get -2. So my vertical asymptote is at x equals -2. Instead of just putting the zeros on my number line for my sign chart, I put the zeros and the vertical asymptotes. So I'm going to have a -5, and I'm going to have a -2. The -5 is 0. This is not an inequality, so it gets a closed circle. -2 is an asymptote, so it gets an open circle. Okay. Then we are going to substitute numbers in just like we did for polynomials, except now it is a fraction, but it's all good. So if I take a -6 and I substitute -6 in the numerator, it's going to give me a negative number. -6 in the denominator gives me a negative number. And negative divided by negative is positive. So it's positive overall. Then I can try -3. So -3 in the numerator gives me a positive number. -3 in the denominator gives me a negative number. So it's negative overall. Then on the other side of -2, I can choose 0. So that gives me positive, positive, and it's positive overall. So positive, positive, negative, positive. And after we do number 2, I will show you why the sign chart's so helpful. But I will tell you this. After we did the polynomial stuff, after 3rd period, I still had it on the board, like I hadn't erased it or taken it down during 4th period. And Mr. Ackerman, who if you do not know, he's next door to me. He teaches calculus A, B, and BC. So he came in and he was talking to me and then he looked at my board and he was like, oh, we're doing that in BC today. I said, I know. So I always tell them, like, we have to use it in here and we're going to use it a lot, but you're going to use it a lot in calculus today. I mean, not today, eventually. Not today, sometime. And that it's simple to do, but it's super important and we use it a lot. So when I say things like that, I'm not lying to you, I promise. Okay, you have to believe me. All right, are we all good with number 1? Okay, so let's look at number 2. On number 2, I do need to factor. So I'm going to have f of x equals x over, and then in the denominator, this will be x and x My signs have to be opposite. So my numbers that go in there are what? Six and 1. And which one's negative? It's negative 6 and a positive 1. Okay. So then when I set that equal to 0, my zeros of the function, what are the zeros of the function? 0. Equals negative 1 and x equals 6. So on my number line, I'm going to put a negative 1, 0, and a 6. The 0 gets a closed circle. The asymptotes get open circles. So then I'm going to choose points. Here I'll choose negative 2. So that would give me negative in the numerator. In the denominator, that would give me negative times negative. So all that together makes it negative. Negative 1/2 would give me negative in the numerator, then positive negative. That's positive overall. Positive 1 will give me positive in the numerator. Oh, not a 1, sorry. Oh, I guess I could have left it made a positive. I get positive in the numerator and then positive negative, so that's negative overall. I can substitute in a 7. That'll give me positive, positive, positive. That's positive overall. So then when I shade, it looks like this. So right now, you may not feel like you know very much about rationals, but I'm going to show you, knowing that this is a rational function, what I do know here. I know where my asymptotes are, right? So, and you don't have to draw this in. I would almost suggest that you don't, just because we're not really going to be doing what I draw on there just right this second, and I don't want it to confuse you. If you want to, it's fine, but you don't have to. But I know that my asymptotes are here and here. Okay, so then if I want to figure out what the rest of the graph looks like, well, I know that this is going to go all the way to negative infinity. So from negative infinity to this asymptote, my function is negative, which means it never gets to cross the x-axis. So if it's going to continue to be negative, I know it's going to come down here, so it's going to have to look like that. Like that's the only thing that could possibly happen for it to be a continuous curve. You with me on that? Then here, this is an asymptote that's positive here, so I know it's going to have to hug the asymptote. This is a 0, so I'm going to cross through the axis, and then I'm going to hug the asymptote over here, so it's going to have to look like this. Like that's the only option based on the signs, and what's an asymptote and what's a 0. And then here, since this is another asymptote, I know it's going to have to be up here, but I never get to cross the x-axis because it's going to stay positive, so it's going to have to look like this. So basically, that's what my graph looks like. Okay, so that's one of the ways it's going to help you graph these, because they're not parent functions that you know what they're supposed to look like. You have to be able to take those signs and take what you know about asymptotes and whatnot and figure out what it's going to look like. Okay, and we'll get there. I just wanted to show you that one. All right, number 3. Let's see, wait a minute. I wasn't going to do all of them. We'll do number 3. Okay. So I need to go ahead and factor. So this will give me f of x is equal to, what is this on the top called? What kind of situation do I have? Thank you, difference of squares. Can we all say that? What is this? Difference of squares. Yes. Okay. So x plus 3 times x minus 3 over x plus 4. Okay. So I'm going to set that equal to 0. So then from this, I'm going to get that my zeros are what? What are the zeros of the function? Good. -3 and +3. So you can write it that way, or I'm going to put plus or minus 3. Either way is fine. My vertical asymptotes, I only have one. It's at x equals -4, right? So we're going to get -4, -3, and 3 on here. Zeros get closed circles. Asymptotes get open circles. Okay, so then you go through and fill out the sign chart without me walking you through it. Okay, so all the ones we've had so far alternate back and forth and back and forth. They're not always all going to alternate, just like they didn't for polynomials. But do we have any questions on this one? Oh, good. Give you a second to finish it. Okay. All right, so we're not going to do the next one. We're going to jump down to the inequalities. So just like for polynomials, we are doing the whole thing, and then we do the same thing we do for the equality part, but then we just have to solve the inequality. So let's look at number 5. Number 5. Okay, so the first thing I have to do is set it equal to 0. It's done. Then I need to factor, if I can. So if I factor the numerator here, this is going to give me x and x. The signs have to be the same but negative. So it's going to have to be a -1 and a -4. Denominator, I'm going to get x times x plus 2, less than or equal to 0. So now that I have that, I can find my zeros. They are going to be 1 and 4. And then I can find my vertical asymptotes. I'm going to get x equals -2. And what else? 0. Yes, x equals 0. So I have 4 things I need to put on my number line. And I have a -2, 0, 1, and 4. The 1 and the 4 are close. Well, actually, to determine this, I need to know whether it's a 0 and asymptote, but I also need to look at this. And so that's less than or equal to, so it would be closed anyway. So 1 and 4 are closed, but the asymptotes are open no matter what. Always, always open. So we'll go through the sign chart together. I have a -3. This will give me negative, negative in the numerator, negative, negative in the denominator. That's positive overall. Then if I have a -1, it's going to be negative, 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 positive, negative overall. If I have the 1/2, that's going to give me negative, negative, negative. I'm sorry, it's positive. So it's still negative, negative in the numerator. It's a positive 1/2. So then positive, positive down here. So it's positive overall. If I substitute in a 2, I'm going to get positive, negative, positive, positive. That's negative overall. 5 will give me positive, 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 positive. That's positive overall. Okay. Everybody good so far? And again, this one alternates again, but if they always alternated, we would just find the first one and go with that. That's not what's always going to happen. So I'm going to shade positive, negative, positive, negative, positive. But this time it says it's an inequality, so I need to actually give the answer. So since I want this to be less than or equal to 0, it's when it's negative. So it's here and here. So I know I'm going from negative 2 to 0. Do I include the negative 2? No, because it's open because it's an asymptote. 0, I don't include 0 either because it's open because it's an asymptote. So if you get it on the number line correctly, you don't have to think about what it is and why when you do it. And then we're going to go from 1 to 4. These are closed circles because they're zeros, so I do include that. Okay. What questions do we have? Okay. Let's look at number 7. So the first thing I need to do is set it equal to 0. So I'm going to need to do x minus 7 over 2x minus 2 minus 1 is greater than, oh, and I want you to change this to greater than or equal to. Greater than or equal to 0. So is this just going to become x minus 8 over 2x minus 2? No, because that's not the way we add and subtract fractions, right? To add and subtract fractions, we have to have what? Common denominator. So that means I'm going to need to do x minus 7 over 2x minus 2 minus 2x minus 2 over 2x minus 2. So this has a value of 1. That's greater than or equal to 0. So go ahead and get the numerator for me. Okay. So this is going to be negative x minus 5. If that's not what you got, think about why I got that. I am subtracting this whole thing. So if you need to put this in parentheses, put it in parentheses. But it's x minus 2x and negative 7 minus a negative 2, which is positive, so this is what I end up with. Now I think I would like to go ahead and factor this a little bit more. I'm going to factor out the negative 1, get x plus 5. And in the denominator, I'm going to get 2 times x minus 1. Because if it's actually factored all the way, that helps me with my signs. I don't have to think quite as hard. Okay, so then from this one, my zeros, let's see if I can scroll over more. My zeros, or the zeros of the numerator, what would that be? If I set the numerator equal to 0, it's going to be a negative 5. My vertical asymptotes, how many do I have? Just 1. Even though I factored something out, that 2 doesn't have a variable on it, so this is just going to be x equals 1. So I'm going to have a negative 5 on here and a 1. The negative 5 is a closed circle. The 1 is an open circle. In this right here, the 2 is not going to affect the sign at all when I substitute stuff in, but this negative does. Because if I substitute in a negative 6, I get a negative inside of here, but then when that negative's out there, it makes it a what? Positive, right? And then if I put in a negative 6 down here, it's negative down there, so it's negative overall. Between negative 5 and 1, I can choose 0. So if I substitute 0 in there, it ends up overall giving me a negative number. And then down here, 0 would give me another negative number. So it's positive overall. If I substitute in a 2, and up here, that makes this positive, but then it becomes negative. This is positive and it stays positive, so overall this is negative. And then I'm going to shade. This is negative, positive, negative. I thought I moved the lines up far enough where we could write our answer underneath it, but I don't know if I'm writing ginormous or I didn't do that, so I'm going to write it under the box. But I want this to be greater than or equal to 0, so when it's positive, so that's just this part right here. That's from negative 5 to 1. Do I include my negative 5? Yes. Do I include my 1? No, because it's open and it's an asymptote. That is my answer. What questions do you have? Anything at all? Okay. Then let's look at number 8. So the first thing I have to do here is set it equal to 0. So I'm going to take 9 over x minus 4, and I'm going to subtract 8 over x minus 3, and that's going to have to be less than or equal to 0. So go ahead and combine those two fractions on your own. It's like what we did yesterday. Actually, just go ahead and you should be able to finish the whole thing without me walking you through it. I'll give you a little bit of a head start, then I'll start doing it. But don't just wait for me to do it for you. Yeah, restaurant money, don't write it pass. It's 2 S's and 2 L's, right? No, it is the 9th. There you go. so do we agree? Everybody agree with me so far? I never include my infinities, right? Do I include -5? Yes, because it's a closed circle, right? Do I include 3? Nope. Open circle. 4? Nope. And that's my answer right there. Okay. What questions do you have? Anything at all? Okay, so let's talk about what is happening Wednesday. If you are a junior, you are testing for the PSAT. If you're virtual, it was an option. So if you're not, then you know if you are or not. If you need to know your testing location, you go to testing.pmhsmavs.com, or there are barcodes around the school. And then y'all will leave at 12:30. You're dismissed to go home. If you are not a junior, then you will be a virtual student, no matter whether or not you're face-to-face right now. Everybody stays at home, and that's not a junior, and everything is asynchronous learning, which means it's student-paced. So you would still expect to have to do something, but you're just virtual, okay? Does that make sense? And remember, make sure you go to satpractice.org. Do at least a little bit of it. It'll be worth your time, I promise, okay? Anybody have any questions for me about any of that? Awesome. Today's assignment is it's there. You click on assignment, the directions are there, but some of us have a really hard time reading directions. It's something that you have to do and turn in on Kami, okay? So either be working on your Delta Math or you can start that work in Kami, either way, okay?